Let's make a VR game together. And in this episode, we are going to make the first interaction of our game by being able to grab an object, throw it into a vortex trash can with a custom shader that we will build together, detect when an object enters the trash can, but also disable the hand model when grabbing an object. As always, feel free to subscribe down below for the next episode about making this cool pistol that can break meteor into little pieces. And if you'd like to support my work and get access to the Result Unity project, I will leave in the description my Patreon. But without further ado, let's get started. Okay, now that we've made our beautiful VR environment, let's create some interactable in the scene that the player will be able to grab and interact with, of course, to make everything feels more alive. Now, if we want to grab an object, you should already know how to do this from my tutorial series on how to make a VR game. You basically need two things: a grab interactable and a direct interactor. So, first, for the direct interactor, we need to add it under here the left or the right controller. And we can basically create an empty game object and add the direct interactor component. Or with the new version of the Unity XR toolkit, there are already some pre-made prefab that we can use. If we go to Samples, XR Interaction Toolkit, Starter Asset, Prefab, Interactor, and there it is. We can drag here the direct interactor under the left controller and the direct interactor under the right controller. Maybe rename the left one left direct interactor and the right one right direct interactor to better differentiate them. And there you go. Now everything should be ready. As you can see, they are using here this sphere collider with a radius of 0.2 to be able to detect an object and grab it. But I think 0.2 is a bit too much, so let's delete them both and instead set them to something a bit smaller, like 0.07. Yeah, this should be good. So now that we have an interactor, we of course need an interactable. So let's see, if we go to the Sci-Fi Modular Pack, Prefab, Extended Primitive, we have here a beautiful cube. So let's maybe drag it here and scale it down, put it on top of our desk, and let's see if we can grab this cube. Now, as you can see, there is already a box collider on the cube, which is great. But what we need is a XR grab interactable. There you go, we can select and press on enter. And as you can see, it has automatically added a rigid body, which is necessary to move and grab the object. Now already, if we click on play, if we put one of the end through the cube and press on the grip button, as you can see, the cube snaps to the position of the thumb and we can now move and grab it. This is really, really cool. Now, something that I want to improve for this grabbing mechanism is first the snapping. So I don't want the cube to snap on the thumb. I want to keep the initial offset. Before, to make this, we had to kind of replace the XR grab interactable with a custom script. But now, as you can see, there is this use dynamic attach parameters that we can enable. And with it, we can keep the initial offset between the interactable and the interactor when we grab it. Let me show you. Okay, here you go. Now let's do the same. Put my hand through the cube and press on the grip button. And as you can see, the initial offset is kept. Everything looks nice. I really think that this looks a bit better. But of course, when you want to snap an object to a good position, the other method using the attach transform is better. And this is something that we will use in the next episode for grabbing a gun, for example. Now, anyway, another issue is that, as you can see, the cube can pass through the table. And this is because the movement of the cube is not using the physics property of the rigid body. So to actually fix this, what we can do is here on the XR grab interactable, set the movement type from instantaneous to velocity tracking. And this should fix the issue. And now if I click on play, as you can see, this is beautiful. The cube does not pass through the table, as you can see. But sometimes the movement feels not precise. This is not something that can be seen on video. But yeah, for example, as you can see, sometimes the mesh can pass through the table. So it means that the physics is not properly working on all of the frame. Now, there are some settings that we can do to improve the physics. So the first one is to go inside our cube here, and on the rigid body, we can set the collision detection not to discrete, but to continuous. And another settings to improve is to go to Edit, Project Settings, then on Time, And here the fixed time step is set here to 0.02. Now on PC, this game turns into 90 frames per second. So we can actually change the fixed time step to 1 divided by 90, which is 0.0111. Perfect. Or what we can do is go in the physics tab, and here we can increase some of its parameter. For example, the default solver iteration, we can set it to maybe 15. And in the solver type, we can set it to temporal gauss saddle. And these are, for example, two settings that can improve the physics accuracy of your game. And let me show you if we click on play. Now I can grab the cube, and as you can see, the movement is way more precise. The mesh does not pass through the table anymore, and everything is working well. So we successfully improved the physics of our game. Congratulations. But of course, this kind of improvement takes an optimization cost, of course, and that's something that we will discuss later on. But for now, let's keep it this way, and let's keep on moving with our interaction in this game. Okay, so now that we have a cube that we can grab, I want maybe to keep this cube and place it on the side. It will be fun for the player to kind of play with the stack of cube if we want. We can even put some on the shelf right there. Beautiful. I think that adding this kind of element that are interactable can really improve the immersion of the player. But now that we can grab an object, I want to use this interaction for one of the first things that the player should do in the game. And that's something that will be understood better in a future episode when the whole picture of the game will be shown to you guys. But basically, the first step that I want the player to do is to take a little rock that falls on his desk and be able to throw it in a trash can. So to do so, let's go to Let's Make a VR Game, prefab. And there, as you can see, there is a space waste ball that we can drag over there. Beautiful. We can add a component, so a mesh collider, and then add the XR grab interactable to be able to grab this cube. But there is a little issue, and this issue is that mesh colliders are not supported for a rigid body. It needs to be a convex mesh collider. So we need to enable this here. And as you can see, this has basically made this mesh, well, convex, which means that if you take any point inside this object, the line that goes between these 2 points is contained inside this convex hull. Now, anyway, with this, we should be able to grab this space waste ball. So to throw it into a garbage can, I'm going to select now the trash can that is over there and put it on the side like this. We can maybe increase the size and put it right there. Beautiful. This is a beautiful space trash can. Now, anyway, in this case, I also want to add a mesh collider. There you go. But as we don't want to grab the trash can, we only want to have a good collision with it. If we throw a physical object to it, let's not make it convex. This means that this object will be kind of a physical object which is not moving. Now, anyway, don't forget to maybe change the setting on the XR grab interactable like we did earlier. So for the movement type, velocity tracking, and for the dynamic attach, let's enable it. And now if we click on play, this should not surprise you, but now we can grab and throw this beautiful space rock. Now, anyway, the goal here is to throw it to the trash can. And as you can see, it is working and the collision is working well. Now, while we are at it, I want to improve the look of this trash can by adding a vortex on top. That's a visual effect that we will be able to create with shader graph. And so I feel like that is something kind of exciting that we can do on this project. So let me show you how we can create a little vortex using shader graph. Okay, so to create the vortex effect, now let's right click, go to 3D object and then quad. And let's rename this one vortex. There you go. We can maybe place it on top of the trash can, rotate it 90 degrees to make it face upward. There you go. We can maybe scale it down a little bit and place it on top like so. I think it is looking really nice. Now we can remove here the mesh collider. And now we want to create a special effect shader that we want to add on this quad. So for this, let's go here on our asset, right click, go to create, then to shader graph and add on URP a unlit shader graph. We can rename it vortex. And now if we double click on it, as you can see, the shader graph window should appear. And this is where we will be able to create the shader graph for this vortex. And so the particular technique that we want to use is the twirl. So let's right click, go to create node and search for the twirl node. There it is. Now, as the name suggests, this twirl node will create kind of a twirl effect with the particular UVs. You can change here the centers. You can change, of course, here the strengths, for example, and you can maybe even offset it a little bit. Now, I think we can improve the twirl effect with a little bit of noise. And so the noise that I want to add is a Voronoi. Perfect. We can maybe drag the twirl effect inside the UV. And as you can see, it creates this kind of thing, which is looking great. Again, you can change here maybe the angle offset if you want, or the cell density. Now I think a value of 2 would be really great. And already, just like this, we can drag it in the base color to see what this looks like. Now let's click on save and have a look at our trash can. Now, as you can see, we want to change the material of the vortex squad. So an easy way to do so is to select our shader, right click, go to create material. And as you can see, this will create a material and already assign the shader graph vortex to it. So let's simply now drag this new shader on the quad. And as you can see, it is working. But now there are two things that we want to do on the shader graph. Kind of first move it in time and then be able to change its color. So to move the twirl effect in time, what we can do is simply offset the twirl node here. So for this, let's right click, create node and search for time. We could, of course, directly drag here the time inside the offset, but something we can do is also be able to tweak the moving speed of the vortex. So for this, I'm going to create a new node, float, and I'm going to right click and convert it into a property. We can change it to speed. There you go. And then we can create a new node of multiply and multiply this speed by the time so that the bigger the speed, the higher the offset it will apply on the twirl. So now if we save and go back to Unity, there you go, nothing is moving now. But if we go here and increase the speed, as you can see, it is moving, but kind of weirdly. And this is because this effect is not updating every frame. And to do so, we can go at the top and click here on always refresh. And as you can see, now it is beautiful. We can see this effect into action. It is really cool. Now, anyway, to change the color of this offset, we can do a little bit what we've done here for the speed, but with a color node. So let's right click, create a node, search for color. There it is. And we can multiply the Voronoi with the color that we have and feed it to our base color. Beautiful. Now we can right click and turn here this color node into a property that we can kept for the name color. Now if we save, go back to Unity, everything is black. But if we change the color to maybe something green, as you can see, it is looking really nice. And ta-da, just like this, we have created a beautiful vortex effect. Now, there is just one last thing that I want to do, and it's if we take this vortex effect outside of the trash can, it is not looking nice anymore. So what we can do is actually kind of create a circle mask to kind of fade the edge of this vortex. So let me show you how we can do this by going to vortex. Then here on the graph inspector, go to graph setting, and for the surface type, set it to transparent. Now, as you can see, we have a new component, which is alpha. And so we will be able to use an alpha mask on this shader. So let's right click, create a node. And for this, search for a sample texture 2D. There it is. And now we can simply set this sample texture in the alpha value. And here for the texture that we want to set, we can set it as a parameter in the shader or automatically set here the default particle, which will, as you can see, fade the quad on the edge because the color is black. And as the color is black, it will be taken as a maximal transparency value. Now let's save and have a look at how it is looking in the game. And there you go. As you can see, it's looking great, but it's kind of transparent. So this is a bit annoying. Now we can tweak this issue by actually changing kind of the transparency value on the mask. And we can do so by right clicking, creating a float node and multiplying the value of the sample texture by this float before sending to the alpha component here. Now let's turn this float into a property that I will call alpha. And now if we save, go back to Unity, it is completely transparent now. But if we increase the alpha value, as you can see, it is now working better. Now, of course, feel free to tweak this shader as much as you'd like. You can, of course, change the alpha mask to have something different. But now we are almost done with the first interaction of our game, which is, if you remember, throw the space waste into the trash can. The only thing that I want to make sure is to check if the player has been able to throw it into the trash can. And for this, I'm going to select here our trash can, right click, go to 3D object, capsule, there it is. We can rotate it upward and put it back at the center. Now, I don't want to have a mesh filter or a mesh renderer. I only want to keep here the capsule collider. And what I'm going to do is set the capsule collider to isTrigger equals true. And this way, with a script, I will be able to check if an object has reached the inside of the trash can. In our case, it will be the space waste. So for this, let's click on Add Component and add a new component called Trigger Zone. Now let's double click on this script to open it. Okay, so to check that something has entered a trigger collider is actually not very complicated. So actually, we can remove here both the start and the update function, and we can check that in the onTriggerEnter function. Now, with this function, I'm going to create two public variables, a public string target tag and a public Unity event. Oh, and for adding a Unity event, we actually need to go at the top and add a Unity engine.event namespace. There you go. And so the Unity event will take as a parameter a game object, and we can call this Unity event onEnterEvent. And now, if the tag of this game object is equals to our target tag, it means that we can trigger the onEnterEvent with here the game object that has entered. Beautiful. And so, as you can see, this is a very simple script, but that is super handy because it can basically tell you all the time when something, so a rigid body, has entered a collider, so a particular zone in the game. Okay, so with this trigger zone, we can set a particular tag, which will only make it happen on the object that have this tag. So for example, if we select here our space waste mode, we can go at the top and set the tag to Meteor. Now, if you don't see this tag, you can click on add tag, then on the plus button, and write basically any tag that you want. Now, anyway, here I'm going to simply set the space waste mode to Meteor. And what we can do is on the capsule collider on the trigger zone, set the target tag to be Meteor. So in the case that the Meteor has entered, we can actually disable it. Now, to disable the Meteor that has reached the inside of the trash can, I'm going to create a new component called trash can. And inside this component, I want to add just one function, which will be called inside trash. And that will take as a parameter a game object that I will call geo and simply do geo.selectIfFalse. So this will simply disable any game object that is inside the trash. And so the last thing we need to do is hook this function to the trigger zone. So we can do so at the start of the game by doing getComponent trigger zone dot onEnterEvent add listener and add here our inside trash function. And it is as simple as this. Now let's go back to Unity. And if I click on play, there you go. If I put the Meteor into the trash can, perfect. As you can see, it is correctly disabled. Now, I know that for now, it feels a bit like a lot of work just to disable one game object, but that is something that we will use a lot later on. So this trigger zone, and most importantly, if we want to make the game progress and be sure that the player has succeeded this interaction, this trash can component will be very useful. Now, anyway, we are almost at the end of this particular part. The only thing that I want to show you as a little gift on this tutorial is how to disable the end when grabbing one of these objects. Now, I want to make this because, as you can see, when I try to grab one of the objects, the end is kind of weirdly placed. And so an easy way to fix this is to simply disable the hand. Now, of course, you can do something a bit more precise with it and kind of create a hand grab pose. And I've previously made a tutorials series about this exact feature on my YouTube channel, Valem Tutorials. So feel free to go and watch it if you want to implement it. But in my case, I will simply disable the end that is grabbing the cube. So let me show you how to do this to conclude these tutorials. So if we select, for example, one of the interactable, let's click on Add Component and create a disable grabbing hand model component. There you go. Let's double click on the script to open it. So on the script, I will need to go at the top and add using Unity engine.xr and using Unity engine.xr.interaction.toolkit. Then we will need two variables, a public reference game object to the left hand model, and you guessed it, a public game object reference on the right hand model. Beautiful. But now there are two questions. How can we detect when an object is grabbed? And how can we detect which hand is grabbing the object? So for the first question, what we can do is actually in the start, get the XR grab interactable, call grab interactable with get component of type XR grab interactable. And then to know when the object is grabbed or not, we can do grab interactable dot select entered dot add listener. So this means that we will fire any function that we put into these parentheses when this object is grabbed. So the two functions that we want to use is a public void hide grabbing hand and a public void show grabbing hand. There you go. Now we can, for example, add the hide grabbing hand into the select enter add listener. But as you can see, there is an error because the hide grabbing hand function needs to have a parameter of type select enter args. So we can simply fix this by creating these parameters and call it args and do the same, but this time with a select exit even args. Perfect. So make sure here to set select enter and select exit. And so for the other, we can do the same with select exited.add listener show grabbing hand. Beautiful. So this way we are able to know when a player has grabbed or released an object. But now, of course, we need to know which hand is grabbing the object. And the easiest technique to do so is to compare the tag of the hand grabbing the object. So for this, in the hide grabbing hand, for example, we can do if args.interactor.object.transform.tag equals left hand. And if the tag of the interactor is left hand, we can then hide the left hand model. Now, else if the tag of the grabbing hand is not the left hand, but the right hand, I guess you see me coming with this one, we can simply set the right hand model to false. And there you go, this is how we can simply check which hand is grabbing the object. Now we can simply copy all of these lines, put them in the show grabbing hand, and instead of false here, write true. Beautiful. And there you go, just like this, I think our script is ready. We can save and go back to Unity. Now, the last thing we want to do is simply go to our left terminator hand that we added in the first episode and add it as the left hand model and do the same for the right hand model. Beautiful. Now, the last thing we want to do is make sure that the left hand and the right hand tag are set properly. To do so, we can go at the top and set here the left controller to the left hand tag. So let's click on add tag, click on plus and create a left hand tag. There you go. We can already create maybe the right hand tag as well. And we can simply now set the left controller tag for left hand and the right controller tag to right hand. But now if we click on play, let's see if this works. And as you can see, it doesn't. The hands keep showing. And the reason is actually that we've set the tag on the left controller and the right controller, but not on the interactor, which is, as you can see, the value that is used inside our script. So there is two ways to fix this. You can actually check the parent tag on the script, or an easier way is to simply go into the left direct interactor and set this game object to be the left hand tag and the right direct interactor to be the right hand tag. And there you go. Now this way, the interactor as well as the controller will be correctly set to the good tag. Now let's try this by clicking on play. And there you go. As you can see, it is working. My hands correctly disappear when I grab the object, which feels a little bit more immersive because the hand is no more really placed. And as you can see, this works really great even if I'm kind of switching hands while grabbing the object. And there you go guys, the first interaction of the game is done. We had a lot to cover in this video, but I hope that you enjoy watching it. Now the next episode is about making a pistol that can break meteor into little pieces, so make sure to subscribe if you'd like to support my work and get access to the Result Unity project. I will also leave in the description down below my Patreon. Now thank you for watching and see you soon for the next episode. Bye bye!